Hello everyone, and thank you for tuning in to this Futures seminar. Today we have the pleasure of hosting Dr. Anders Sandberg in the studio with us. He'll be here to give a talk about his upcoming book, Grand Futures. After the talk, Anders and I will be having a short discussion about the talk, and then thereafter we'll give you, the audience, the floor for any questions you may have had throughout the seminar. Who am I? My name is August Liljenberg, and I work as an editor here at the publications team here at the Institute. To those of you who might be new to us, we are an independent, non-profit futures think tank, founded in 1969. We work across the spectrum of future studies and foresight, helping people and organizations imagine, work with, and shape their future. And while I still have the floor, I would like to plug our most recent issue of Farsight, the Institute's quarterly print publication, which is very fittingly for this conversation about humanity's future in the cosmos, from space politics to the search for extraterrestrial life and everything in between. You can grab a copy by visiting our online web shop, or if you really want to sponsor and help and you really like the work that we do here at the Institute, you can support our work by becoming a Futures member, where you receive 10% off our courses, receive a quarterly print subscription to Farsight, and unlimited access to our knowledge archive here at the Institute. Now, the topic of today's seminar, Grand Futures, is a bit different from what we have usually presented here in our seminars at the Institute. Usually, we explore what the future has in store from within a certain area, be that artificial intelligence, geopolitics, climate change. But this seminar will focus on the future from a more meta perspective. Taking a step back, how grand could the future get in terms of wealth, well-being, computation, survival? How might we want this future to look like? And how might we get there? Well, we may very well have the best suited person in the futures community to discuss these topics with us today. Dr. Anders Sandberg is currently a senior research fellow at the Future of Humanity Institute at the University of Oxford, working alongside other prominent futurists such as Nick Bostrom and Toby. Originally starting his research career within computational neuroscience at Stockholm University, he has since broadened his interest to an unsurprisingly grand level. His current research focuses on the ethics of human enhancement, global catastrophic and existential risks to humanity, reasoning about emerging technology and other highly uncertain topics, the search for extraterrestrial life, and long-term trajectories for human civilization. Anders, welcome to the seminar.
Thank you so much for having me. It's daily to be here.
Fantastic.
So, the story here began really with a simple question. How big is the future? Somebody asked me that, and of course, I'm in the philosophy department. I started wondering, how do you even answer that? What do I mean by big? So I have been thinking about this project for a number of years now. Basically, trying to say something about how large the future can be. And large is one kind of measure. That's a physical measure. We can think about how far could we go into space, or how long could we survive. But you can also think about what we want to fill that future with. How much can we achieve? And achievements can be of various kinds. It can be amassing very big piles of gold, or building great monuments. Or it can be being very happy, or creating enormous health or enormous amount of justice. So here we have a different set of dimensions, including a very important dimension. How good can the future be? By different measures, you can say, well, we can achieve certain material wealth or certain levels of justice. But can we actually say something about where the limits are? And of course, we might also want to find a pathway to those potentially really, really good futures, or try to avoid those really scary possibilities that also seem to be possible.
Fantastic. And well, I'll let you take the floor for your presentation for the next 20 so minutes. All right?
Yeah, I'll rush through it, and then we can get into the questions that no doubt are going to show up.
Perfect. Cool.
Thank you. Okay. So when people started thinking about the future seriously, that was probably long before written history started. Although in most societies we tend to think about the future just like we think about the mythical past. It's a good story, it's a framing device for our culture rather than something we think is a factual thing. Most of the time we live in ecological time, we're milking the cows, we're going to jobs, we are thinking about how we're going to pay off our house. It's the practical things that happen. And then surrounding that, there is a bit of structural time. We have the years going past. We might have ways of measuring eras. We might read about our family's deeds in the past. And for a long time, people were making predictions about the future that mostly kind of entertainment or part of religion. But more recently, the scientific worldview made us realize that there is this time outside human experience, a deep past. Geologists started poking around and realized that these rocks indicate that Earth is much older than our scriptures have told us. It's older than our history. Indeed, it's much older than humans. Indeed, much of Earth's history happened long, long before human history. In astronomy, astronomers were also noticing timescales much bigger than our everyday timescale. And as the scientific worldview advanced, it became clear that you can make some predictions about the future too. Astronomers realized that it's not just that the universe seems to have exploded out of a big bang. We can actually say some things about the far future of the universe. If things continue like they have, we might end up with a universe that's fundamentally different from the universe we're currently living in. And to many people, these deep past issues and deep future issues give a sense of vertigo. It's like standing there on the edge of Grand Canyon and seeing the millions and millions of years stretching out below you. And many of them with a story that's very alien to us. And the question we might ask as humans is, of course, well, will the story about the future also be alien to us? Will it be that there are no humans around, that there is nothing that we value that's going on? Or could it be that it's going to be filled with humans or other things like humans that we care about? So I'm trying to understand how to reason about this. And this is not always easy. Predictions about the future tend to have a rather mixed track record. We can sometimes be precise about how well we can talk about the far future. For example, predicting the weather, we know fairly well how many days out we can make fairly good weather predictions. Making more vague weather predictions over large areas actually works better than the local ones. And we can make climate predictions that go much further into the future. Meanwhile, if we want to predict where solar eclipses are going to happen, we can easily go 1,000 years into the future and be very certain about where the solar eclipses are going to happen. That is quite amazing, and the reason for that is, of course, that the way planets move and rotate is extremely regular. There are variations, but they are again possible to quantify up to a point. It turns out that beyond about 5,000 years into the future, we can't predict where the solar eclipses on Earth are going to be. Not because the moon or the sun might be moving to weird places, but simply because Earth's rotation itself is a bit uncertain. It depends on the atmosphere. It depends on how spread out the atmosphere is. It depends a little bit on rock motion inside Earth's mantle that changes the length of the day by a tiny fraction. And over thousands of years, that adds up, and the map of where the solar eclipses would be gets a bit out of sync. Yet, climate and the solar eclipses are very nicely regular ones. We have opposite things, like fashions. When people imagine the fashion of the future, it's mostly a joke. Quite often a beautiful or entertaining joke, but we know that we cannot predict fashions because we don't want predictable fashions. If you knew what would be fashionable next year and told people, it wouldn't be fashionable. You want to do something that's very different from everything that previously existed, yet stylish enough. And the same thing happens on the market, of course. If you know what stocks are going to rise and fall, you're presumably going to invest according to that, and that disrupts the pattern. You get anti-predictable behaviors, and they typically happen because humans are trying to be unpredictable, either in games or in economic competition, or just because it's interesting to be different. There are also problems with predicting technology because they are based on ideas, and you can't predict an idea before you have it. So that is why it's so hard to predict how good software is going to be in the future. Meanwhile, Moore's law, how powerful microprocessors get, has been fairly steady over many decades. It has shifted a little bit in character. It used to be about how many transistors you could squeeze in on a chip. But gradually it became more clear it's about number of computations you can do per second per dollar. But over time, technologies change. Back in the early 2000s, making processors run at a higher clock speed didn't work anymore because they started overheating. And you couldn't shrink the transistors quite as efficiently as you could do in the past. So people started instead making multiple cores in the microprocessor. Now we're using graphical processing units in big calculations. People are shifting the technologies and the overall trend remains stable. But how it's made up, the components, are very, very different. So this tells me a bit about my project about talking about the long-term future. There are some aspects, like the astrophysics of where stars and planets are going, that I can just lean on very standard methods. There are some aspects where I might be able to do something like climate studies. There are ways of simulating things over long periods of time. We can make estimates, for example, of how long the biosphere on Earth remains habitable as the sun slowly gets brighter. But we cannot say anything about what humans are going to do. This is a bit of a problem because that probably matters a lot for how good the future is. But we can put bounds on what's possible. And that is typically what I do in this project. I'm not arguing that humans in the future are going to achieve this, rather that they could achieve it if they wanted to. And maybe they figure out that this is unethical or bad for the environment or just not something you do. Or they go for it. I can't say that, but I can at least show the bounds of what we can achieve. Another way of reasoning about unknown technologies, which is, after all, one way we humans push the limit, is to do what I call exploratory engineering. There are some technologies we know work because they exist. We have our computers, we have our clocks, we have our steam engines, and there could be better clocks and steam engines. There are some limits, however, on how good a clock can be. Quantum mechanics literally puts a limit on how accurate a clock can be. Steam engines cannot generate pressures beyond a certain point simply because of properties of water and steam, etc. You can't build a computer larger than a certain size because it implodes into a black hole. So that means that there is a realm that is actually forbidden by physics we understand and a realm of things we understand well. And in between, we have hypothetical technologies that we can analyze. So what I do in my gigantic book project is that I'm working through what we know about these things. So some technologies we already have. There is also many things that are done in nature that we don't know yet how to do, but historically we know humans have been pretty good at copying nature. So for example, plants take sunlight and convert that to useful energy. We have made solar collectors. They don't work in the same way as a plant does, just like an airplane doesn't fly in the same way a bird does. But the existence of plants and birds tell us that you can do this. And it's also interesting to note that this involves some pretty powerful technologies like self-replication and intelligence, which, if we get them, might really change the game. Indeed, we have also found that when we can do something technologically, we can quite often make a machine that does that task. And typically that speeds up or amplifies that activity enormously. If you have to hire people to do something, then it's slow, it's expensive, people get tired and make mistakes. If you can make a machine that does the same task, you can leave it running 24/7. And this tends to scale up technologies a lot, especially if you use machines to make machines, which is increasingly what our civilization is doing. And one of the interesting things here is that suggests that many of the scales we are used to are no longer barriers. Our ancestors would have said that it's inconceivable that there could be millions of people living together. There is not enough food to go around. We have scaled up agriculture. We no longer rely on hunting. We have scaled up the way of making caves, or rather artificial caves like our houses. We're literally making liquid rock, concrete, and are building things out of that, which allows us to make as much buildings as we need. And in the future, we should expect this to continue. It looks like the real limiting factors are fundamental aspects of physics, things like energy and material and time, as well as the knowledge on how to manage it. There might be some technologies that we can never figure out, but most of them seems pretty plausible that we can figure out. And then we can do hypothetical blueprints showing that this is doable, at least in principle. And we can even make silly blueprints that are easy to analyze, even though no sensible engineer would ever want to build a machine like that to show that this might be done. This was demonstrated in the past when people were considering going to space. In the 1930s, people worked out fairly detailed blueprints for how to send somebody to the moon based on the rocketry of the day. This was the British Interplanetary Society. And then they stopped publishing during the Second World War for obvious reasons. And then they began straight after with a new issue of their journal where they updated the rocket design based on the experience of the war and felt like, this looks even more plausible. Indeed, some decades later, we got the actual moon landing, which was a much better design than what they had analyzed. But they could demonstrate that this ought to work. And similarly, we can analyze many outrageous possibilities for the future. So I'm going to rush through some of it. Generally, it seems like we are living at an unprecedented high material standard today. And we're certainly worried about its environmental impact. But the laws of physics seems to be pretty okay with all of humanity living at these levels of material wealth in a sustainable way. There are actually pretty plausible reasons to think that we can do recycling, energy production, etc. on vast scales that at least would mean future generations could have our standard of living in a sustainable way. That might still warp and change the environment in interesting ways. Having a big humanity on Earth is definitely going to change what Earth is like. There are also interesting possibilities about how we might change ourselves. This is a bit beside the point of my book, but I've done a lot of research about the ethics and possibilities of human enhancement, and it looks like there's a great deal of potential here for improving our well-being, for our health, for our longevity and mental capacity. Again, even a small change there would probably make the future outrageously different from what we got. But when we move deeper into the future, it seems very clear that we might want to expand into space. We can imagine the minimal viable product, something like the International Space Station, where people can survive for at least a few years. If you equip that with a way of mining asteroids and turning that material into solar collectors and space technology, if they were self-sufficient on food, which might just take tanks with algae or yeast, then it looks somewhat plausible. We're mostly uncertain actually about reproduction, but humans could live in space, build new habitats over a lifetime, move into those habitats, and slowly convert asteroids into small space habitats. That already looks like it could lead to a future population of something like 10 trillion people if we used up all the asteroid belt. Most likely people will not want to live like that. You need to be a bit of a weirdo to want to live on the International Space Station. It's not an entirely nice environment. It's probably not good for kids at all. Mostly people would probably want something like the grand, beautiful space station envisioned in the 1970s, where you have big rotating cylinders where you can have your parkland and all of that. But that takes a lot of work. And whether we get this kind of advanced space soon or much later, it's very hard to tell, because that's a matter of policy and economics. I can't make any good predictions about that whatsoever. However, the laws of physics certainly allow it, and given that people are interested in doing it, and the costs are coming down exponentially, it seems that within the next few thousand years, it would be rather weird to bet against people wanting to do that settlement. If we could settle the solar system, we could have populations that could consist of trillions of people. If we could move to other solar systems, then at least the Milky Way is available, and we're talking about 300 billion star systems. Populations like 10 to the power of 29 people, which is pretty impossible to imagine. There are some pretty deep technical problems in moving over interstellar distances. The most plausible methods in the somewhat near term is probably laser-propelled light sails, and they are not very useful for sending human passengers. So it might very well be that it's not humans that would be settling the galaxy, but artificial intelligence and nanotechnology. The same technology that you could use to settle the galaxy is probably also available to settle other galaxies. After all, you just need to push things a bit further. It's still the same problem. You need to move over a long time span, over a long distance, but there is no friction. The main risk is that you run into dust particles. So I've been studying how far we can actually go in space. And the main limiting factor here is the expansion of space. There is literally galaxies we can see that we can never ever reach, not even if we moved at the speed of light. But that still means that there are billions of galaxies we, in principle, could send space probes and settlements to. And we're talking about populations that are truly, truly vast, spread out across literally billions of light years in an expanding universe. Other technologies that look fairly plausible are Dyson spheres. This is an idea that the physicist Freeman Dyson suggested in the 60s for what to look for advanced alien civilization. He noted that civilizations seem to use more and more energy. So in a few thousand years, we are going to be using about as much energy as the sun radiates. Could we actually capture all of it? And he sketched out in this paper that you could have orbiting energy collectors, solar panels, and get the 10 to the 26 watts of energy the sun releases. He was mostly interested in looking for the waste heat for an installation like this, because that would surely be a sign that there is an advanced civilization somewhere. But when you start doing the math and analyzing how you could build this and what technology you would need self-replicating robots to turn asteroids into more robots and solar collectors, etc. It could be done in a surprisingly short time if you have this form of exponential technology. My estimate says a few decades once it really gets going. You could use this sphere, of course, to have as a living area. You could have a lot of habitats orbiting the sun. You could also, of course, use these solar panels and put computer chips on the back and run it as an enormously big computer, literally able to simulate all of human history in a few seconds. But you can also put sensors on this vast swarm of satellites and use this as a ridiculously sharp telescope. And of course, you can use the energy and these antennas to send messages over intergalactic distances. And if you focus that, you can be like a naughty child with a magnifying glass and actually burn planets light years away. Fortunately, it turns out that it's not a great weapon. And it's also very obvious where it's coming from, so people are going to assign the blame rather accurately. You can actually use this to push stars very slowly, or you can put a lot of this energy into light cells and accelerate them over vast distances. These numbers and these ideas obviously sound absurd to our current thinking, because we're having trouble enough to power ourselves without a lot of fossil fuels. But this is where you see where the limits of physics and the limits of what we can engineer actually show that there is plenty of room to grow. And similarly, we can grow in time. If we are lucky and well coordinated, we might survive as long as a mammalian species. And that's typically about 1 million years. We have 10,000 years of kind of known written history. We have existed as kind of species for a few 100,000 years. The future could definitely be several times bigger than the past, even if we only last like any other mammalian species. And if we actually learn how to reduce risk on a serious scale, if we actually grow up and learn how to reduce existential risk, we would probably be able to survive even mass extinction events, which would mean we could survive for about 1 billion years before Earth's biosphere starts getting into trouble. Again, I think we can do something about that in 1 billion years, partially by doing something like a solar shield, a bit like the Dyson shell, or something much more clever. We have plenty of time to think about that. Yet, if we moved out to the asteroid belt and started building space habitats, we would have 5 billion years before the sun really burns out. 5 billion years, that's slightly longer than Earth has existed. And were we to settle the galaxy and go to stars that are shining, we have trillions of years ahead of us. And if we actually make use of the energy sources that do exist, it's possible to convert matter to energy by using black hole accretion disks. We might be able to survive up until matter itself decays, somewhere beyond 10 to the power of 33 years. An absolutely unimaginable span of time. And that might, of course, be also if you think about it as thinking or computation. The number of computations that are physically possible is also absurd. It's on the order of a Google computations. And probably we can do far more if we use some more clever forms of computing. So what can we do more? Well, we can literally move stars and galaxies using a lot of aluminium foil. Basically, by reflecting starlight, you can use stars themselves as some of the wussiest rockets you can imagine. But the nudges you can give using orbiting reflectors, they are enough to, after a few million years, make stars come close to each other. So they do gravity assist. And now we're moving much faster and you can direct them. You can do clever things by having multiple stars interacting in complicated, chaotic pathways. And basically, you can play around with swarm robotics on a galactic scale. Why would you do this? Well, one reason is that in 10 to the power of 20 years or so, the Milky Way will otherwise dissolve. The stars are randomly interacting, and some get thrown out, some get thrown into orbits closer to the center of black hole. Over a really long time, an unmanaged galaxy becomes uninhabitable. We could keep it habitable. We might also manage the expected collision between the Milky Way and Andromeda. Not to stave it off, but perhaps manage it so the stars end up in good orbits and all that enormous energy of two galaxies colliding is just stored up for a rainy day later. So generally, I think that what is happening is that life is a kind of phase transition of matter. It takes up normal matter and energy and converts it into more life, organized matter that's good at self-replicating and evolving. And it right now doesn't look like it's a big player on the cosmic scene. Right now, the universe looks like it's full of gas and galaxies and dark matter, and none of that life matters. It might just be a thin sheen on top of one planet in a small galaxy. And there is this scale called the end of greatness scale. It's about 200 megaparsec. We're talking about a few hundred million light years. Beyond that, the universe looks like it's fairly homogeneous. There doesn't seem to be much structure. On a smaller scale, you get galactic voids and hyperclusters, a lot of structure. But on this vast scale, there might not be anything beyond that. But if intelligent life go out and start moving galaxies around, for whatever reason the intelligent life want to do, they could reorganize things on the order of about 100 million light years. That's about as big as you can go before the expansion of the universe prevents you from moving your galaxies together. In what way would you like to move them together? Well, that depends on your civilization's visions of what the good life is, or even whether they think it's a worthwhile thing. Also, intelligent life could spread up to about 12 billion light years. We could hence end up with a situation where we have bubbles of life spreading from where they originate, creating a pattern laid on top of the normal cosmological pattern that is set by fundamental constants of physics that determine whether life occurs and how often it is. But also the interior of these bubbles is going to be determined what intelligent beings think is reasonable. They might have very different views. They might have crazy or dangerous views. They might have beautiful views. We don't know. But the interesting part is that in the long run, a lot of the cosmological structure might actually become dependent on what intelligent life decides to do, rather than what just happens naturally because of gravity and nuclear fusion. So intelligent life might be a force to reckon with over the long-term future. And this future is open. It's not like it has to be a particular way. Gravity forces matter together. Intelligent life makes more unlikely states of matter happen, whether that is artworks or microprocessors. So if we have this kind of grand future, if we spread far and wide and gain control over matter and energy, what should we do? Some people say, oh, we should be creating happiness. We should be turning as much of the universe into life, intelligence, consciousness, or whatever has value. And that is what we should do. So go out there fast. Others would say, yeah, actually, this might be more like thinking. We should perhaps spread a bit and then wait until the universe gets into its late autumn, when it's getting cold and you can do a lot of computation. And that's where we should start spreading. Others would say, no, we should spread out as far as we can without losing contact and keep in touch, because what really matters is our civilizations. And that is what we should do. Others would say, wait a minute, let's survive for a long time. And some people are saying, wait a minute, I want my little cottage. I don't want any craziness. Moving galaxies, who cares? I want a modest future where I have reasonable social expectations and some finite scale. I think in general, all these things are valid. I think actually we can probably make trade-offs. It might be possible to have your nice little cottage while others are going out there moving the galaxies. I think there is actually a lot of things to investigate about what advanced civilization might be interested in doing, because we might want to look for that, just like Freeman Dyson said we should be looking for these spheres collecting energy. My main message from this book is that the future looks like it's potentially enormously big and bright and grand. Practically any measure that we care about could become much bigger in the future. Doesn't mean it has to be. It could be that we fail now. It could be that we should be really careful about not missing out on this grand future because we have a nuclear war or pandemic destroying our chances before we get started. The bigger and longer you think the future is, the more cautious you will want to be not to lose it. Also, if we expand very widely and become very diverse, we might have a hard time actually making plans together. We might make use of the fact that we're all stuck on one planet right now, just a seventh of a second away from each other. Many of the things that many of you probably find hard to swallow are based on technologies that we anyway might want to develop in various forms. We have self-replicating technology in the form of computer viruses, perhaps not a big win. We might be interested in using something like that to make solar panels in space. We are developing various forms of space transport. We are figuring out how to do automated manufacturing to solve many of the problems down here on Earth. And I think one of the interesting things here is seeing these possibilities. Some of them might not be very likely on their own. But the whole point of having a brain, being an intelligent being, is that we take we survey the environment around us, and then we figure out a way of making that environment work in our favor. We make traps, we make dams, we construct devices to put the world into very unlikely but useful states. It's very unlikely that we could find so good caves as the houses we have. So we invented a way of making houses. It's very unlikely that we could communicate by shouting very loudly across the sea. So we built telecommunication systems that allow me to speak to you and to record this for future generations. That is the power of intelligence. It takes possible things and allows us to make them likely. Sometimes, of course, we notice horrible threats, and we can work on using our intelligence to make them unlikely. And finally, one message I think is important for our civilization right now, right here, is to have hope, to actually recognize that actually the future can be bright. There is this strong anti-utopian streak in our current culture. People think that the people who are optimistic about the future, they are naive. Only the doomsayers are serious. Yeah, but the doomsayers are not very useful for fixing the risk. If you think the future is worth saving, then you will want to go out and save it. And you might also want to be optimistic about your chance of doing something useful. Even if realistically you think that you have very little effect, it's much better to actually get that energy. And I think also when we unfold our own lives, our art, our culture, our civilization, it's much better to have hope, because that makes a life that's actually worth living. Because the real grandness of the future will be in our heart, hopefully also in the heart of a lot of future generations, whether human, post-human, artificial intelligence, or something we can't imagine yet. Thank you.
All right, well, thank you so much for that talk, Anders. There are seriously so many different topics and things that I could start this discussion from us, between you and I. But I'm going to focus on the last two slides, because I mean, those are the ones that are kind of a call to action. There's a question at the end of them. And I think I kind of want to start off with value, because and how it affects decision-making in the present. When we talk about the long-term future, tens if not hundreds of thousands of years, how do we make rational choices in the present to achieve such futures when the future of humanity may very well have different values than ourselves? I mean, we can see that if we go back just 1,000 years into history, or just 100 years' time, human civilization held very different values and beliefs that we hold today. And if we think that, you know, the progression and change in values will keep on developing exponentially, then we have no way of kind of expecting how human civilizations in not only 50, but, you know, 10,000 years' time might be. So in that case, if we need to make decisions today that affect the future of humanity, do we sort of have to defer to some kind of basic values like maximizing pleasure, minimizing pain, or what could we do?
I think Going for basic values is a smart move because, as you say, we don't know much about the cultural values. Even if you're a very optimistic person and think that, yes, there is moral progress, we're actually getting more and more ethical over time, we are, in that case, most likely committing horrible moral crimes and we're not even recognizing them right now. And if we don't recognize them, we have a real problem in fixing them. But on the other hand, we can prevent, for example, the future from not coming to be by if we destroy ourselves in a nuclear war. That's obviously going to be very bad for the future, no matter what values it holds. And I do think there are similar simple things. Just saying going for pleasure, that might not necessarily be the best value, but like keeping our options open. So if future people realize, yeah, pleasure actually turns out to be the one true value, who would have thought? In that case, they have that option. Forestalling different futures can be a very bad thing. If we imagine the Romans being able to decide what values we should have today, we might have been stuck with the Roman ethics, which I think we today would say is rather crude. It has some interesting points, but yeah, we have learned things in philosophy that actually makes us question it, and we think validly we have learned important things that should change course. So being able to change course, being able to survive, that seems to be robustly good. And then we might just want to hope that future generations also live up to their promise.
Right, so it's about keeping the possibility of the future open rather than perhaps striving for certain kinds of values. Of course, well-being in some kind of loose sense is what we should strive forward, but having some kind of limited definition there. And I'm wondering, because you spoke about how future generations might sort of judge us, they likely will judge some things that we do today as deeply immoral. And sort of linked to that, I'm wondering, what do you think are the most significant sorts of blind spots that humanity has today that posterity will judge us harshly for not taking action on?
The interesting thing is that the really big one, the one that we're kind of really in trouble for, according to future generations, I can't imagine. And you can't either, because it's the thing that we're totally missing. Yeah. However, we have a lot of stuff that is, we kind of know this is iffy. Just like even the ancient Greeks, they kind of recognized that slavery has some bad sides. And then they stopped thinking about it and went to other areas of philosophy. But they were kind of aware that was something. Today, for example, we have a factory farming. I think it's pretty obvious that that's likely to be something history is going to be harsh about. We might also say that our lack of coordination, we are having some trouble coordinating about climate change and AI. Future might be unhappy about that, especially if we miss opportunities that could be taken to give the future something better. Generally, irreversible actions, they are the most important ones to get really right, because you can't redo them.
And I mean, sort of linked to that as well, some of your research also focuses on existential risk, and you mentioned climate change and AI there. What do you think, if you could kind of list the top three in order, the biggest existential risk, I really want to push you there, kind of. What would it be?
I'm an old-fashioned risk researcher. I think nuclear war still tops.
Really? Still top?
And many
Why
of my
is that compared to AI? Because I mean, some of your colleagues, does Bostrom believe, your colleague Nick Bostrom, does he believe it's AI?
He certainly thinks AI is much more concerned.
Right.
My argument is, right now, at this moment of this recording, nuclear war risk is still higher than AI. Right now, the large language models are merely annoying. They haven't killed many people yet, but they are rapidly becoming more powerful. Nuclear war, on the other hand, is definitely something that could kill hundreds of millions of people, relatively straightforward, and might threaten literally billions of people because of nuclear winter. On the other hand, it might not necessarily wipe out humanity, but still, I'd rather not have that kind of disaster. Biorisk is similar. We know how bad pandemics can be, and COVID-19 wasn't as bad as it could have been. It could have been a much more deadly virus, and people are getting better at making deadlier viruses. That's scary. But at the same time, we're getting technology for controlling this. AI is the tricky risk, because maybe it's true that we're overblown about the fears about AI. Maybe there isn't that much. But there are also arguments that suggest that this is a very serious risk, and we don't know how to handle it well yet. So we should probably be putting in a good effort at making sure that, if nothing else, having artificial intelligence that do what we want and understand what we aim for and our well-being seems to be a very good thing on its own.
And just briefly linked to that, I can't help but think about current events in the past couple of months, notably the OpenAI drama where Sam Altman was ousted as a CEO by the board of what many called in the community, particularly the Twitter community. It seems to only be kind of localized to that ecosystem for some reason, as always is. But they kind of blamed it on effective altruists in the board. And the institute of which you work is often associated with effective altruism or long-termism. And that's kind of been pitted against this other strand of effective futures, which is known as effective accelerationism, which kind of has the philosophy that we should move fast and break things because artificial intelligence will, with a high likelihood, promote welfare and well-being in humanity rather than being a catastrophic risk. Do you have any kind of take about this schism that has suddenly opened up in the past month in the kind of futures community?
Yeah, I'm finding it rather amazing because I was part of a transhumanist movement in the 1990s. I was on the Extraterrestrial mailing list. And if you read the old issues of Extraterrestrial magazine from the 90s, you realize they sound very much like the accelerationists today. But then many of us grew up, or rather, many people in the AI safety field, many people who are working on existential risk, actually grew up in this field. We realized that the future looks super bright, but some of these technologies are so powerful that it's actually probably a good idea to figure out how to do them safely. I think the accelerationists, they need to grow up. Meanwhile, of course, when you're on the side of let's be cautious, you can easily be too cautious too. So I'm kind of in the middle. I'm getting called a doomer, but at the same time I'm
You're
kind
a transhumanist.
Yeah, So I want to genetically upgrade myself and live forever and literally see the Milky Way and Andromeda merge. And I want to be super intelligent thanks to AI support. But I'm also apparently a doomer because I think maybe we should make these systems safe before we let them loose on the internet.
And just kind of related to you being a transhumanist and human enhancement, a lot of these kind of visions within grand futures seem to be based upon, they kind of nested in making things grand, better, smarter, cognitive enhancement, longevity. But you also mentioned towards the end this idea that some people have of humble futures. They want to be in their cottage. Why is it, first of all, why is it that you think some people might want to wish for such a future in that way? Or let me rephrase it. Do you think necessarily improving the welfare of humanity in the future is about maximizing, longevity? That well-being is kind of located in maximizing longevity, cognitive enhancement, etc. Basically, well-being as it's like understood in most conventional terms, or is it more complex? I can't help but think about Aldous Huxley's novel Brave New World, which kind of paints human enhancement and longevity and all these things we typically associate with grand futures as actually like a negative thing, and where all the whole population is sort of doused and drowsy from soma, a happiness-inducing medication all day, but nonetheless they are happy in some sense of the world. Do you have any take about that? How well-being manifests itself when we talk about it in the future?
I think you want a spectrum of well-being, from the instantaneous well-being when you bite into a delicious piece of chocolate, over to a happy mood, over to having a personality that makes you walk through life with energy and purpose, over to have life project that makes sense, over to eventually having a life well lived that you can look back on and say, yeah, that was very tough and very painful, but I did what needed to be done to do what was important. You want the full spectrum. You want your happiness diet to kind of cover it all. The Brave New World is about a world that has narrowed things down to some of the easy forms of happiness. And I do think that we should aim at getting that. There is way too much pain and depression in the world, and we need to fix that. And that might actually be fixed by drugs. But there is also things that need to be fixed by changing structures in society. There are issues of justice. And there are many projects that we don't even know yet are meaningful. Many artists are kind of poking at the boundaries of what we have been thinking and feeling and trying to see, can I move this out and do something that didn't exist before? I think plurality is important. I want a plural future where there are nice little cottages on some planets and galaxies are being moved around and super intelligence are thinking deep thoughts, and there are very, very happy mice or counterparts on alien planets. And it all goes on for a very long time, because I don't know which one is best. If any of them is the one true form of value that we should judge the universe. So maybe we should hedge our bet and try to do all of it.
Right.
All the things that are compatible.
All of it rather than none of it.
Yes.
Right. And then before we go to Q&As, I simply have to, since we have this publication right here, I have to ask you about extraterrestrial life. You know, do any of your grand calculations about grand futures, you know, for example, the value of resources in outer space, what we could feasibly kind of settle in the cosmos, is that dependent on there not being extraterrestrial life that could have taken those resources already?
It depends very much on the density of intelligent life in the universe. It could be that it's very, very far away. So you go out there and...
Do you think there is extraterrestrial life?
I think the universe is spatially infinite, so I think it's hard to avoid.
Right.
But I think it's sparsely populated. So it's very possible that we go out there and we never find anybody, and somewhere, literally a trillion light years away, aliens are wondering, where is everybody? Or it could be that it's slightly more densely populated. So in a billion years, in a galaxy far, far away, we suddenly find a spacecraft we don't recognize.
Right.
I think that is actually a somewhat likely scenario. In that case, the total amount of stuff we could get our hands on is becoming finite, because unless we're fighting the aliens for it, we have to split it between them. I think a densely populated universe, where you really need to kind of have your elbows out in the Milky Way, is unlikely, given that we don't see much. I've done some calculations in other papers, and I end up very much leaning on the perhaps pessimistic, perhaps optimistic view that it's sparsely populated. But it does matter. And one interesting question that comes up is, of course, if you encounter another advanced civilization, is there any point in having a conflict? It seems like low-tech civilization might have more reasons to take stuff from each other than advanced civilization, where most of the resources are the same, because you can interconvert between different forms of matter and energy much more easily.
All right, and with that, let's head some questions from the audience. I've got a laptop here.
Awesome.
Which we can get some stuff from. See what kind of questions the rascals in the audience have come up with. Right. Should we just... Okay, this one we've kind of covered already. Let's take this first one by Juuso Rantanen, who writes, do you think knowledge of the future is possible given the epistemic limitations of temporality? That is, can the owl of Minerva in fact fly at the dawn and not in the dusk?
Oh, that's beautiful. Yep.
Someone knows their stuff here.
Oh, yes. Oh, yes. Yeah, time has a lot of awkward properties, and the main one is, of course, it only flows in one direction, which in some sense is good. The reversibility of things actually has a lot of moral implications too. But that means that the amount of information that we get from the past is better than the information we have about the future. Indeed, the question about what is a prediction or a forecast, what do I learn if I hear you make a prediction, it's a philosophically deep question. And I think the real value is, what actions do I do differently? There is far too much futurism that is just entertainment. We talk in front of a corporate boardroom, and they feel like they're having foresight, but we don't change anything. A real futurist might tell them, your business idea is dying and you better get out of this business. They might not get paid. That might be a problematic thing to say, but that might be action relevant. Recognize that, here is a risk that we need to deal with, or here is a possibility that if we grip it now rather than later, we get much more. That is kind of epistemically valuable thing. So it's not so much that we know the future as we getting useful advice.
Okay. Let's say we've got one from the Biomimicry Innovation Lab, which write, what science fiction books or films do you look at for clues or even for ideas that are so far-fetched they get it all wrong?
Yeah, so my favorite one, which is in some sense kind of the grandfather of my book, is Olaf Stapledon's Star Maker. It's amazing. It's also from the 1930s. It's ancient. It's very dry. It really doesn't have any protagonist except intelligence across the history of the universe. Okay. All sorts of imaginative alien civilizations rise and fall. But the science is super obsolete by now, but the vision is really, really amazing. And then, of course, there are interesting things like Accelerando by Charles Stross and The Quantum Thief by Hannu Rajaniemi that are kind of just dense with ideas. I like these novels that are full with ideas, even if some of them don't work, because that stretches your mind about what's possible. Then you won't need to read history, of course, to see what is actually also possible. History.
What do you think is more useful, history or science fiction?
I think both have their uses. So sometimes you need to stretch your mind to start imagining ways things could be radically different. But you also need to recognize that things have been radically different. And that is also very valuable to see.
All right. Then we've got one from Anders Nissen, who writes, many of us have difficulty thinking even a few years ahead and to understand cosmic distances, etc. Are we struggling against basic human cognition in trying to have us think about the deep future?
I think that's very true.
Yeah.
We are the kind of beings that are good at understanding physics on this scale, with objects weighing something on the order of a kilogram, moving about a meter per second. And we get very confused when we get to quantum mechanics and relativity theory. But we have learned how to think bigger. If you go to the Greek philosophers, Archimedes, the sand counter, was kind of a first attempt at dealing with very big numbers. And he created some tools. They were tough to understand. And we today would say, yeah, it's still hard, but we're better at it. We're more used to big numbers. And I think we can train ourselves. I think we actually can become better. But it's going to be a long uphill story.
I found that a lot of people, including myself, people can't even conceive of numbers larger than 100, 1,000, a lot of people. So just trying to think of 10 to the power of 35 in your presentation is crazy.
I tried one version of a presentation of this metaphor of a human life as a fine dust grain, and then all of us 8 billion people on Earth there would be kind of almost fit into my hands. So, nice image. But then I kept on going through my talk for the various futures and talking about the bigger and bigger dust piles. And at first it was merely covering the stage and the Great Pyramid. And then I ended up with the rings of Saturn. Nobody has a sense of how big the rings of Saturn. Oh, the dust as big as the Sagittarius supercluster. Yeah. Okay, we have no idea what we're talking about there.
Right, we've got a question from Simon Östergaard, who writes, what's your P doom? The probability of doom. The morbid question making rounds in tech. P doom is a term to signal your opinion on the probability of AI destroying humanity. A high probability of doom means you're a doomer. You think AI is developing too fast and recklessly. The hot trend in tech apparently is discussing your probability of doom number.
Oh yeah, I've been to a breakfast in Silicon Valley where we've been talking P doom, and kind of a consensus around the table was about 10%.
10%.
Yeah.
Right.
Now that doom, it's not on its own a valuable thing. You want to think a bit about the scenarios. What is it that is risky? And there is the good old scenario you find in Nick Bostrom's Superintelligence about you get super intelligent machines that have goals that are different from us, and they make themselves more powerful. That one I give maybe a few percent. I think much more likely is that we kind of sleepwalk into a world where we have actually really useful AI agents. We use them everywhere. It would be stupid not to. And then we find that, we're actually not in control anymore. The AI agents are, in some sense, not in control either. But now the entire world is accelerating along in some random direction. So it's not so much the big computer.
That takes kind of an idea of like an autonomous singularity within technology, kind of operating itself without any kind of agent.
Instead of the one big computer that has some malicious or neutral plan, now it's just something like the market is just moving off.
Like the market.
You have other possibilities also of stuff going really badly wrong, like malicious actors using it, or totalitarian societies becoming totally locked in. Using super intelligent surveillance, you can always keep your population in check. And eventually, the rulers also get controlled by the surveillance. And now you have this locked-in humanity that just marches on forever until it hits a wall.
Fantastic. Right, okay, the next question we have from Matthias Schneider, who asks, can you think of a science fiction movie or book which portrays a world which you would like to live in?
That's tricky. I'm very fond of Ian Banks' culture novels. So the culture is a super civilization. They have friendly, nice, super intelligent machines, and they're spending most of their effort having fun. But there's one thing that is rare in such a utopia, and that is actually doing something meaningful for somebody that needs help, because most people don't need any help. So they are interested in helping other civilizations that are not quite as well off. Of course, the problem is you can't show up with a 100-kilometer spacecraft and just start raining down blessings on people. You need to be a bit subtle, and that's where the intrigue and plot come in. And quite often you find, we're getting into very morally tricky areas. That's one setting I find quite interesting.
And that plays into your kind of vision of a diverse and pluralistic future. But it's also one that has civilizations which are less well off than others, and etc.
Yeah. And it might very well be that in the long run, all civilizations are as well off as they would wish to. However, there might still be profound disagreement about whether that is a good trade-off. That civilization that went for the simple life, they can't cure certain diseases, so some people are still suffering from it, while their slightly more advanced neighbors, or at least they think they're more advanced, say, you should really cure that disease. And the others have said, no, thank you. It's totally natural that some children are born that way. That is creating this interesting moral conflict. And I think we are not going to see an end of conflict. Hopefully we're going to be more friendly and peaceful conflicts, more like bickering in the United Nations than actual military stuff. But I do think that there are going to be tensions across the future. A diverse future is not necessarily going to be a quiet future.
Then we have a question from Dogus Koinuku, who says, do you think AI will have the same existential concern as we have right now, to understand our position in the universe and how to extend our existence as humans for reaching heat death of the universe?
Yeah, you could say that an existentialist AI at least know who created it, but then it might think, okay, I want to survive. Oh, I'm still made out of matter, just like those squishy humans. I still need to deal with proton decay. The heat death of the universe threatens every form of organized thinking.
Yeah.
So that's
the absurdity of death will still hit them.
Yeah, right. And you might get very different answers. We humans deal with it in one particular way because we are kind of have bundled things, but the end of us as beings is also the end of our bodies and the end of our consciousness. If you're an AI program, you might have backup copies and different versions and exist in a very different way. But you get other forms of absurdities of death. I can imagine existentialist AI philosophers having very odd takes on what it means to have an upgrade.
Do you think, I'm just thinking from an existential standpoint, with the advent of mind uploading interfaces, for example, do you think it will change on a human level, like the existential worry people have about death? I mean, you yourself are going to be cryopreserved. You have the medal there, if we can get a zoom-in shot of that. Anders wears this medal that says, what does it say on it?
Well, it's instructions for the healthcare system that if I'm dying, well, follow this instruction, call this number in America, call with ice, give CPR, inject all the heparin you can find and start the cryostasis protocol. Whether that is actually going to work is, of course, a big gamble. But the point is, I'm willing to put my money where my mouth is as a futurist. The interesting part here is, of course, that could I find that I'm waking up now as a software emulation of my brain, because instead of repairing that squishy thing, they just scanned it and replicated it in a computer. I'm okay with that. I'm a functionalist. I think this could actually work. I also have an idea of personal identity. That means that all sufficiently Anders-like processes are me. So I'm totally fine in existing in plural. But I have friends who say, no, that's just wrong. Software can't be conscious and personal identity doesn't work that way. I think many people are going to have very different views. In the long run, of course, I expect that the software people are going to be a minority just because it's easy to copy. And so they are going to win at least the number of people believing certain things. But the others are going to say, yeah, but they're actually bad copies of the original. Okay,
cool. Then we've got one last question, which is, when is the book coming out, Grand Futures?
Yeah, this is where I'm cringing, because it's an enormous manuscript, 1,400 pages. And I think the best way of estimating it is actually using the Lindy effect. That is, if something has been going on for a certain amount of time, you should expect to be at a typical point in that time span. So you should just double it. So I've been writing for about 5 years, so I should expect 5 more years.
I see.
On the other hand, I think I'm 99% done with the core argument. It's just that there's so much that needs to be fixed. On the other hand, I try to speed up because I'm worried about those cosmologists. They might discover what the dark matter or dark energy is, and then I would have to recalculate all things in the later part of the book, and that would be such a chore. You
have another book coming out in March, did you say?
Well, at
least
next year. I'm submitting that to the publisher. Okay. So that one is about laws, artificial intelligence, and Leviathan. How does our social systems and institutions work right now, and how might they be changed if we introduce artificial intelligence into the equation? How do you safeguard human autonomy in a world where you have intelligence on tap?
All right, well, everyone in the audience, look out for that book. And with that, Anders, I would like to thank you for this conversation. It's been a really interesting discussion. I've certainly been looking forward to this talk for a very long time now, and I've been blown away from the breadth of your expertise from today and also when we had lunch with some colleagues at the Institute. And thank you, the audience, for tuning in. If you thought the seminar was interesting, we hope that you'll consider getting a copy of Farsight via our online shop, or perhaps signing up to become a Futures member at the Institute to make sure that you receive future editions as well. We'll put up a QR code at the end of the live stream on the screen. Again, thank you all for tuning in, and I hope to see you at our next Futures seminar in a couple of months' time. Thank you.